Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about feature selection. This topic is based on a tech blog with the title Optimizing Feature Selection with Generic Algorithms, an easy-to-use Python script, written by the data scientist team from justeattakeaway.com. You can find the blog link in this episode's description. Throughout this episode, we will dissect the topic from both business and data science angles. Now let's dive in. On the business side, let's take a look at the problem to be solved. JustEatTakeaway.com is a leading global online food delivery marketplace headquartered in Amsterdam, Netherlands. The company was formed through the merger of two major players in the food delivery industry, Just Eat and Takeaway.com. This is where the name comes from. In the United States, the company's subsidiary Grubhub is more well known for the local market. Acquired in 2020, Grubhub partners with a wide range of restaurants, from local eateries to national chains, to offer consumers a diverse selection of food options through its website and mobile app. The company leverages machine learning to enhance its operation and customer experiences. A few key applications of machine learning includes personalized recommendation based on customer behavior, dynamic pricing strategies involved, optimized delivery routes considering traffics and weather conditions, and automated customer support using natural language processing. Those are different machine learning applications, and machine learning supports the company's day-to-day operations to provide it with a competitive edge. Within machine learning, a feature is an individual measurable property or characteristic of the data being analyzed. Features are the input variables used by machine learning algorithms to make predictions or classifications. The quality and relevance of these features significantly impact model performance. It could lead to more accurate and robust predictions. However, in production machine learning at the scale of Grubhub or JustEatTakeaway.com, especially with its large datasets and complex models, there is a tendency to create an excessive number of features over time, which is called feature explosion. This can result in model overfitting if incorporated into the model directly, where the model learns noises rather than the underlying patterns. It could also increase the computational complexity and reduce the model interpretability. Therefore, model selection is essential for addressing this issue caused by feature explosion. The feature selection involves in identifying and selecting a subset of relevant features for model training, which helps to reduce the dimensionality and avoid overfitting. Effective feature selection and engineering is critical for building high-performing and efficient machine learning models to ensure that the features used can provide meaningful and useful information for the tasks at hand. This is a key problem the team at JustEatTakeaway.com aims to address in this blog post. Now that we've understood the business context and the problem to solve, let's dive into the technical side to see what could be a good solution. Regarding feature selections, there are various common methods available. This includes filter methods, wrapper methods, and embedded methods. Let's quickly look at each of these to have a better understanding. The first type of method is called filter method. Filter methods use statistical techniques to evaluate each feature independently of the model. For example, the chi-square test can be used to measure the dependency between each feature and the target variable. This allows the selection of feature to have the highest correlation with the target. The second type of the method is wrapper method. Wrapper methods assess feature subsets based on the overall model performance. For instance, recursive feature elimination is one type of the wrapper method. It involves iteratively building a model and removing the least important features based on model performance, such as the features with the smallest coefficient magnitude in linear regression, until a desired number of features is reached. The third type of feature selection method is called embedded methods. Embedded methods incorporate feature selection during the model training, using techniques like regularization to penalize irrelevant features. An example of this is lasso regression, which it adds a penalty equal to the absolute value of the magnitude of the coefficients. This results in some coefficients being reduced to zero naturally through the training of the model, and effectively performing feature selection by excluding less important features. Each of these three types of methods has its strengths and is suitable for different types of data and modeling scenarios. They help to manage complexity and improve model performance. Well, there are still key challenges arise when features are highly correlated. In these situations, standard feature selection methods focus on individual feature importance may miss such interactions. This can result in only local optimum solutions rather than globally optimized ones. Now we know the challenges of the standard feature selection methods. Let's introduce the generic algorithm. Generic algorithms offer a distinct approach to feature selection. It leverages principles of natural selection and genetics. They use a population-based search to optimize the selection of features, evaluating a population of feature subsets rather than individual features. This approach allows generic algorithm to consider interactions and dependencies between features, leading to more holistic feature selection approach. Meanwhile, the stochastic processes involved in generic algorithms, such as mutation and crossover, introduces randomness that helps to explore the feature space thoroughly and avoid local optimum. Additionally, generic algorithms evolve a population of solutions over generations, using a fitness functions to guide the selection of the best feature subset. And this can adapt to various objective functions. This global search capacity and flexibility makes generic algorithms particularly effective for complex and high-dimensional feature selection tasks. We understand the principles of how it works. Now let's take a look at how a generic algorithm works for feature selection in practice. First, we initiate by generating an initial population of random feature subsets. Each individual in the population represents a potential solution, or a subset of features. Next, we evaluate each subset using a fitness function, such as the accuracy of a machine learning model trained on that subset of features. A higher accuracy indicates better fitness. Then we select the feature subsets with the highest fitness score to be parents for the next generation. Followed by being selected as parents, here comes the mutation or crossover process. The crossover process combines pairs of parents to create offsprings. It involves the exchange of the parts of the feature subsets between parents to produce new subset. For instance, if parent 1 has feature ABC and parent 2 has feature DEF, a crossover might produce offspring with feature AEF and DBC. There could be future mutations being introducing more randomness to individual feature subsets to maintain a generic diversity. Mutation can be carried out through adding or removing features at random. For example, a subset of the feature ABC might mutate to ACD. The generation update steps replace the current population with a new generation of feature subsets. And then this process is repeated until a set number of generations are completed or the convergence criteria are met, such as no significant improvements in fitness would be observed. Now we understand the general steps. Imagine that you have a dataset with 1,000 features, and you need to select the best subset for a classification task. You start with 50 random subsets of features, train a classifier on each subset, and measure the accuracy on a validation dataset. You then choose the top 20 subsets based on the accuracy, create 30 new subsets by combining or slightly modifying the top 20 subsets, and then replace the old population with this new 30 subsets. By repeating this process for 100 generations, you evolve a feature subset optimized for this classification task. This is a more vivid view of the generic algorithm process. This approach is likely to outperform subsets chosen by traditional feature selection approaches due to the global search capacity and flexibility of the generic algorithms. Now we discussed both the business problem and technical solution. Let's wrap it up. In this episode, we discussed the potential problems that can arise from having too many features for a machine learning model. We also explored several methodologies for feature selections and took a deeper dive into the generic algorithms and how it works step by step. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.